In this question, we are going to learn about L'Hopital's rule. So finding some limits which are indeterminate and we using L'Hopital's rule. So let's work on the first one. Limit x approaches to pi over 4 sine over x minus cosine of x divided by tangent x minus 1. If I try plugging in pi by 4 here, so sine pi by 4 is root 2 by 2 minus root 2 by 2 divided by 1 minus 1 is going to be 0 by 0, which is called an indeterminate form. Okay. If we have a limit which is in the indeterminate form, then we can say this limit is same as limit x approaches to a f of x by g of x is same as using L'Hopital's rules to limit x approaches to a f prime x divided by g prime x. This is what is L'Hopital's rule basically. So we are gonna, because this given limit is L'Hopital's, we can't indeterminate, we can't really plug in pi by 4 in it. So we can use L'Hopital's rule for it. So that limit is equal to, using L'Hopital rule, limit x approaches to pi by 4. What is the derivative of the numerator? Cosine x plus sine x. What's the derivative of the denominator? The derivative of denominator is just secant square x. Derivative of 1 is 0. If we try to put in pi by 4 now, cosine pi by 4 is root 2 by 2 plus sine pi by 4 is root 2 by 2 divided by secant square pi by 4 is, secant pi by 4 is root 2 whole square. So what do we get? 2 root by 2 in the numerator divided by 2 here. So this cancels. The answer is root 2 by 2. Let's work on part B. Limit x approaches to 1, x to the power 7 minus 1, x to the power 3 minus 1. If I try to plug in 1, 1 minus 1, 1 minus 1, that is 0 by 0, which is an indeterminate form. So we can apply L'Hopital's rule to it. We can't just put zero values in there. So using L'Hopital's rule, this limit is same as if we find the derivative of the numerator 7x power 6 divided by derivative of the denominator 3x square. And now if we try to put in 1, what we get? 7 times 1 power 6 divided by 3 times 1 power 2. 7 by 3 is your answer. Let's try the last one. Limit x approaches to infinity, x times tangent 1 by x. If I plug in infinity in there, this is infinity. Tangent 1 by infinity, 1 by infinity is 0, tangent 0 is 0. So this is infinity by 0 form. So we don't have direct infinity times 0 form as an indeterminate. So first step is we can rewrite it. Let's see what I'm doing. Tangent 1 by x divided by 1 by x. If I write it like this becomes 0 by 0 format. And now I can apply the L'Hopital's rule. So L'Hopital's rule says I need to find the derivative of the numerator. What's the derivative of tan secant square 1 by x times negative 1 by x square derivative of 1 by x because of the chain rule. Derivative of denominator is negative 1 by x square. We can cancel this. So what do we have? Limit x approaches to infinity secant square 1 by x. When x approaches to infinity, 1 by x approaches to 0. Secant square of 0 will be 1 because cosine 0 is 1, so secant 0 is 1. The answer to the limit will be 1.